Good morning, everyone. Myself Abhishek Ghosh, and today we are going to discuss the topic classification and nomenclature of igneous rocks, and it will be covered up gradually. So this is the part one only, and to start with, first the definition of igneous rocks: any rock which has been formed by the cooling of magma or lava on the earth or below the earth surface is called igneous rock. Based on their mode of occurrence, it can be called as extrusive when it forms on the surface, and it can be uh, called as intrusive when it is solidified below the surface. But more or less, these are the broad classifications of igneous rocks, and in this whole lecture we will be covering the need of classifying the igneous rocks, what is the need, why it has to be classified. Next, a few basic classification schemes of igneous petrology, then the basic concept of grain size, phenocryst and ground mass, then primary igneous rock forming minerals name, formula along with the same of the accessory phases, and then the limitation of color based classification scheme, and then Hatch and Wells classification, which is one of the old classification, and last but not the least, the photographs of few igneous rocks we will be discussing along with the rock forming minerals and few important textures. So first, the need and of the classification and nomenclature of igneous rocks. At first, geologists used to do field work. So in a hand specimen, it is very important to mark a rock as a particular lithology in field in the map, which will enable us to study further about that rock. And then comes the laboratory study, in which under microscope we do thin section study, petrography, and the preferred method of classifying any rock, whether igneous, sedimentary or metamorphic rock, is based on the texture and composition, preferably mineralogical composition. Actually, texture texture provides the best evidence for rock's origin and genetic classification. See, the main motto of science is to know the truth, and to know the truth, we have to look for something which will tell about its origin, how it has come into being. So that is very important thing. So that is why the texture and mineralogy tells us the actual story. There are many methods, there are many technologies by which we can know several aspects regarding the geochronological studies enable us to know that when did the rock form, at what age or range of age that rock formed. And then texture used to say that how did the coarser grains form, how did the finer grains form, whether they formed at the same time or whether they formed in metastable condition at two stages or multi stages. These kind of things are the tool by which we can know about the origin of the rocks, and that is the ultimate motive of any classification scheme. To know how the rock has formed, we have to first broadly classify the rocks into several groups, and then we can assign the history of origin to different groups, or based on the origin we can divide several groups. So there are many classification scheme based on many parameters. So after observing any igneous rock in field, as a layman, what should we do first? So we should first determine whether the rock is phenolitic, that is, the grains are visible under naked eye, which means generally the larger grains or visible grains are formed in plutonic or intrusive rocks. Due to their slow cooling rate, crystals get time to form or to take the shape of crystals of different system. For that, the detail of crystal systems, 7 systems or 7 class, like triclinic, monoclinic, trigonal, hexagonal, orthorhombic, tetragonal, and isometric. Those 7 systems of crystallization will be covered in crystallography lecture, but here we will be concentrating on the igneous aspects. So one is phenolitic, whether the rock grains are visible under naked eye or that cannot be seen under naked eye. Then the rock can be named as aphanitic, which is generally true for volcanic or extrusive rock. Due to their high rate of cooling or rapid rate of cooling, the melt phase or elements do not get enough time to reach the specific lattice position, and that is why the rocks or the solid form does not have any particular structure. The solid form from that rock cannot have any particular structure, and the rock's grain size of the mineral become very small. So these are the aphanitic rock whose grains are so small that cannot be seen under naked eye. And then the fragmental part, the pieces of fragments, pyroclastic rocks. And now the glassy and phenolitic rocks and their grain size. Other than these 3 types, phenolitic, aphanitic, and fragmental rocks, some other type of rocks are also possible, or a 4th type, that is glassy type texture, where no crystal even formed due to very rapid cooling or quenching. Only amorphous glass used to be present in these rocks. And then comes the phenolitic igneous rocks. It can be of fine grained, less than 1 mm dia, that is basalt. Then it can be of medium grained, that is within 1 to 5 mm range, sample dolerite. And coarse grained, 5 mm to 5 cm diameter, longest diameter, is sample gabbro-granite. And very coarse grained rock, greater than 5 cm diameter grains, that is visible for hematite. And porphyritic refers to one texture when the bimodal grain size distribution we used to get, and in next slide we will go into that detail. So the phenoclist and ground mass, the main 2 important aspects. But before that, the equigranular and inequigranular grain concept has to be there. So the phenolitic and aphanitic rocks just indicate a particular grain size. Now, one rock is an assemblage of mineral or is composed of many mineral grains. So sometimes it may be possible that all the mineral grains have uniform size. Then in that case, the rock will be named as equigranular rock, or else they can exhibit a range of sizes. Now, this variation of grain sizes can be very gradual, like a few grains you are observing of 4 mm, then gradually it grades into 3 mm grains, then 2 mm, then 1 mm. In such a way, if one gradual change might be there, or it might be very abrupt, means 1 4 mm grains is engraved within the assemblage of 1 mm grains size or less. So a distinct difference our eye can observe in case of such abrupt grain size variation. So if the texture displays two dominant grain sizes that vary by a significant amount. The texture is called inequigranular texture, particularly in case of bimodal variation. The texture is called as porphyritic texture. So, larger crystals in general thought to be formed of earlier, and though exceptions are there, called phenocryst, while the finer crystals are called ground mass. So, call it a phenocryst means, suppose a 4 millimeter grain is engraved within the ground mass of 1 millimeter grain, it cannot be called as a phenocryst. For calling it a phenocryst, you need to have at least 5 times larger grain than the ground mass. So that is the first and foremost requirement. And then, while referring a rock as plutonic or volcanic or hypabyssal, we need to consider the grain size of ground mass, not of the phenocryst, as those are considered in general to be formed earlier. So at the time of final crystallization, the ground mass carry most of the signature of that rock. So that is why the grain size of ground mass is actually referred as the grain size of that rock. So if you are getting 6 millimeter grain phenocryst within ground mass of 1 millimeter grains, and based on that grain, because that grain is covering more area, more volume, you are saying that this rock is coarse grain to very coarse grain, then you are completely wrong. You have to check the grain size of ground mass only before concluding the grain size of that rock. Of compositional terms, the one parameter is that the grain size of the rock to classify. Now, other parameters include nearly all igneous rocks are composed principally of silicate minerals. So those minerals are broadly in two categories, and one is felsic. Felsic minerals, main constituent principal minerals are quartz, plagioclase, alkali feldspar, and muscovite, while mafic minerals are those which are dark in color, like dark gray to black and opaque, and those mafic minerals include biotite, amphibole, pyroxene, and olivine. At the beginning, those who are at the first week or first month into geology or earth sciences, you may find difficulty with these names, but believe me, gradually you will be habituated with these mineral names. So in lecture of mineralogy, I will cover detail regarding about these mineral phases, and these are called principal igneous rock forming minerals. In addition to this, few accessory mineral present in the igneous rocks in very small quantities. Those accessory minerals are of few types. Silicates include epidote, apatite, zircon, spin, tourmaline. Oxides include magnetite, ilmenite, and rutile, and sulfide grains are also present. Classification based on color index and mineral. Now, another classification scheme. One we have covered about the grain size. Second is about the mineralogical composition, felsic or mafic, which one is dominant. And another classification can be based on the color, which is not very reliable, but still, and the color actually gets reflected, since felsic minerals are light colored and mafic minerals are dark in color. So color is basically a reflectance of the proportion of felsic and mafic minerals in one rock. As per color index, the rocks can be classified as leucocritic, mesocritic, and melanocritic. Leucocritic means the light colored rock, and melanocritic means the dark colored rocks. And as per the relative content of felsic and mafic minerals, classification scheme is such: felsic rock, where felsic minerals dominate over mafic minerals, and mafic rock, where mafic minerals are dominating over felsic minerals, and ultramafic rocks, mafic minerals consist greater than 90% of rock. So these both can be used as complementary classification scheme but other, but we have to be careful because some exceptions are also there. These things doesn't mean that felsic rocks has to be leucocritic always. So one very common example, or that common example, we have an example of felsic but melanocritic rock. And for that, we have to know something about plagioclase feldspar. Plagioclase feldspar, CaAl2Si2O8. This is the chemical formula of plagioclase feldspar, and is actually a solid solution series. While studying crystal chemistry and mineralogy, I will be having one separate session regarding solid solution and mixed solution series. But for the initiation of igneous petrology, just we have to consider that in plagioclase feldspar there is a solid solution series exists, and in that solid solution series there are few end members like A and B, and in between A and B everything is mixture of A and B with different proportion. Suppose in case plagioclase feldspar, we have at one end sodium feldspar, that at the base of the triangle on the left, the NaAlSi3O8, this is sodium feldspar or albite, and this is one end of solid solution series, and at another end it is CaAl2Si2O8 100%, it is anorthite. So this is the plagioclase group minerals composition: albite, oligoclase, andesine, labradorite, bitonite, and anorthite. You can easily remember this as first is in albite, that point at the apex of Na, Ca is 0. So 0 to 10% is albite, 10 to 30% is oligoclase, then equals with 30 to 50 andesine, 50 to 70 labradorite, 70 to 90 bitonite, and 90 to 100 of Ca is anorthite. At Ca apex, Na proportion is 0. So the point here relevant is this labradorite, bitonite, anorthite. Since anorthite content or Ca content is greater than 50%, this labradorite, bitonite, and anorthite species of plagioclase feldspar which you cannot identify naked eye, can confuse us because they have a color of dark gray to even black. So plagioclase is a felsic mineral. Its color is not always very light colored, can be of dark color. So now suppose a rock contains above 50% plagioclase falling in anorthite 50 above range, which is commonly dark gray or even black in color, obviously that rock will appear melanocritic as per color index, but as per mineralogical composition it is a felsic rock. And for example, anorthosite is such a rock which can be observed as or identified in field as melanocritic, but it is actually containing felsic minerals more than mafic minerals. So due to these problems, this kind of index classification scheme based on color is not very reliable and will take us to nowhere from where we can interpret about the origin of the rock. So the classification based on mineralogical composition, as because there are such overlaps, various classification schemes classification based on chemical content is some including, and among that classification, the basis of silica content is of prime importance. So the term acidic is synonymous with silica content. Though Beaumont in 1847 has coined the term acidic, unfortunately, based on an outdated concept that silicic acid is the form of silica in solution and melt, which is not true. But still then, the term is in use, and as per the convention, we consider that the silicic rocks are acidic rocks. And opposite to that, the opposite of acidic is basic chemistry. So silica poor rocks, that is basalt, they do not have a high pH value, which is actual indicator base. But still, since it is silica poor, and that is why, since silica rich rocks are called acidic, silica poor rocks are given the name of basic rock. This is the convention. Therefore, classification is acidic, which contains 66% above percentage CO2, intermediate, which contains 52 to 66% SiO2, then basic, which contains 42 to 52% 8% SiO2, and at last ultra basic, that is less than 45% SiO2. So the next slide will give detailed idea about some old scheme of classification, that is H&Wells classification scheme for phenolitic igneous rocks, and it is based on silica content. Second, relative component of proportion of alkali feldspar and alkali feldspar, and texture, whether coarse grained, fine grained, or medium grained. This is the classification scheme actually, and the need of this knowing this classification is that it will never come in exam. But before going into the IUGS classification scheme, which is the existing classification scheme in igneous rocks, before that we have to be habituated with the names of the rock, and for that this classification scheme is just a homework type thing. Go through it, and it is very easy. Its x-axis, here you can see that feldspar content. Alkalic means alkali feldspar is to plagioclase feldspar, that ratio is greater than 2:1, and zonitic means alkali feldspar to plagioclase feldspar ratio is lying between 2:1 to 1:2, and calc-alkalic means they are just the reverse. Alkali feldspar and plagioclase feldspar ratio has to be equals to 1:2 or even less than that. Means alkalic means alkali feldspar is the dominating part, intermediate part is mononetic, and plagioclase dominates over alkali feldspar, that is called calc-alkalic. And already we have discussed about the acidic, intermediate, and basic rocks. Now third component is coarse, medium, and fine grain. Now see alkali granite, and everywhere medium grain one prefix micro will be added, except in case of basic rocks with calc-alkalic composition, where you can see the bottom right corner that gabbro is the coarse grain variety, and dolerite medium grain variety, while fine grain variety is basalt. So the same composition of the rock, the coarse, medium, fine grain, is given rise to three different names for the rock, and this main side actually tells about broadly tells about the rate of cooling during crystallization. That is why it has a genetic implication, and that is why three classifications of rock is possible from here, which is relevant for its origin. Now photographs and example. Granite, it can be classified as phenolitic, medium to coarse grain, as you can see the grain size and the height. and it is leucocritic because it is full of or majorly of the form of felsic minerals. Next, affinity, and vesicular vessel is red, spots are red, holes are basically vesicle, and this exclusive of affinity and you cannot differentiate much. Then the fragmental or pyroclastic, you can see that angular grains are engraved in a very fine mass. So this angular grains comes from the ejection material after rupturing. So this actually means this fragmental nature. Clastos means fragments. So this kind of textures are called pyroclastic texture. Pyro means fire and clastos means fragmental. So fragmental pyroclastic rock. This is glassy obsidian, which is amorphous. You cannot differentiate even any fine crystal here. Everything is like smooth and there is no such crystal structure. Everything is amorphous. This is the practical result of quenching of a melt. Now the principal rock forming minerals, quartz. These are the varieties of quartz, rock quartz. And then plagioclase on the top left, orthoclase, the brownish color. On the top right, muscovite, shining, colorless, flaky nature, muscovite, and biotite, which is a mafic mineral, but major constituent mineral, the bottom right. And now on the top right is amphibole. This is a hornblende. There are few amphiboles which are tremolite, actinolite, which have needle shape, but that is not the constituent of igneous rock. Tremolite, actinolites are common in metamorphic rocks. So here amphibole means preferably hornblende. And at the bottom right there is pyroxene crystal. That 8-sided nature actually indicates that it is an augite. What is augite you will be knowing later with the growing knowledge of mineralogy. And at the bottom left there are the greenish color grounded or sub-rounded pieces are actually olivine. Olivine is very prone to or very susceptible to chemical weathering and hydrothermal alteration. That is why it alters. And the top left photo is of serpentine, which is actually not the constituent of essential constituent of igneous rock, but olivine is generally altered to this mineral. That is why I have kept this photo of serpentine, so that in field if you look anything like this, you will be counting that it could be olivine which has been altered present to serpentine. Now the accessory minerals: on the top left epidote, on the top middle ilmenite, on the top right that's fin, calcium and titanium rich silicates. In one important mineral, and then the bottom left photo is of betite, bottom middle photo is of rutile, titanium oxide, and bottom right photo is of magnetite. They are present as accessory case in igneous rocks. Now the variation of intensite. So you remember that H&L's classifications, the bottom right part of the classification, that coarser grain is gabbro, medium grain is dolerite, and fine grain is basalt. And there are few texture. Porphyritic texture is possible in both granite and basalt. And tourmaline rich pegmatite. The black mineral is tourmaline, triangular in cross section and striations present in general. It can be a middle shaped also and found in granite as an accessory minerals, or in pegmatite. It is very common, and pegmatite is the example of very coarse grained rock actually. So the conclusion, we have an idea of initial classification scheme, but in next lecture, actually this lecture is the basement, is making the basement of knowing the IUGS classification scheme and its need. So we have seen that many classification schemes exist, but they have their own limitations. So, and another thing is that various countries geologists use various terminologies. That is why during 1960s and 70s, the International Union of Geological Sciences, that is IUGS, formed a sub-commission on the systematics of igneous rocks to develop a standardized and workable system of igneous rock nomenclature worldwide. So, to explain IUGS scheme in detail, we need to have a different session, and in next session we will be covering every aspect about IUGS classification scheme, and it's very important to understand the plotting system differently, and what to classify and how to classify, and which minerals we have to consider in which way before classification. So this lecture you can consider about the basement forming lecture for IUGS classification scheme, along with the knowledge, basic initiation of or initial knowledge of few rock forming minerals, not few, every rock forming minerals in igneous rocks, and with some older classification scheme which are very important. The rock names will be same in other IUGS classification scheme, but this will actually strengthen your memory, and this will clear the concept of the felsic rock or mafic rock. Well, these terms are very important because you guys will be hearing these terms in near future. So before going to any person or any professor or any field, you should know that what is felsic, what is mafic. If you got confused there, then it will be very difficult for you to cope up with him or her. So that's all for the first day, and thank you.